Okay, to begin with for today, we are doing a little bit of review, and I have a picture for you. You guys are visual learners and visual people in general, and so here is a picture that's got a couple roots, 2 and 8. And my question is, where does the vertex have to be? I'm going to assume there's no stretch. Figure out where the vertex is with that dotted line technique. Okay? Assume there's no stretch, and you should be able to write me an equation, and you'll find the vertex. It'll be at like 3 comma -2 or something like that. I'll pause for a minute while you give that one a shot. Remember, write the equation. You can always write the equation if they give you the vertex or if they give you the roots. There's no stretch. I'll pause while you give that a shot. All right, so hopefully you knew that exactly between the 2 and the 8, what's exactly between there? That's the halfway point. 5. Why do I know it's 5? Because that's 3 away from this and it's 3 away from that. And then another way to do it is you take these two and you average them. All right, so good. We know it's at 5. X equals 5, but that's not the vertex. It's 5 comma something. The only way to get it is if you know the equation. Emmy, can you write the equation? You are so right. And now, Mr. Wilson, what do I do with that equation? It is factored out. Try again. Okay, you could FOIL it out, you're right, but in the context of wanting to know this, let's not do either of those because that would give me general form. Nothing wrong with that, but if I want this, what do I do? Maybe you don't know. I'll help you. Maybe Shirley will help you. Plug 5 into this. 5 and 5. And then that becomes 3, that becomes -3. Have you noticed the pattern? They're always opposites. 3, -3. Okay, when you multiply those, that makes what? 3 times -3 makes -9. Raise your hand if you had 5 comma -9. All right, good. Now, let's flip that and make these not work out quite as nice because one's negative and one's positive. And now, if there's a stretch factor 2 involved, then figure out, okay, the stretch is, we're always going to do vertical stretches, by the way, just because how they kind of really complicated with factored form and everything. It's just easier to throw a number in front, so we'll always do vertical stretches if we're going to do stretches at all. So anyway, it's a vertical stretch. Good point. And this is, the whole goal of this question is to tell me the vertex. Find the vertex. Yes, sir.
Wait, so are they even? Because one on the left is negative however much.
The way I'd think of this one, is how far apart are 9 and -3? How far apart are they? 12. That's the way you got to think. If they're 12 apart, then figure out how much to the middle, and then you can do it. I don't want you to tell me the answer out loud. Everybody figure out what the dotted line is down the middle, and that helps start the process. Remember, a picture is worth 1,000 words. What they're going to get you on this test is they're going to just say, well, the roots are this, and you're going to be like, what does the picture? I don't get what the picture looks like. Make a picture. The roots are the same as the zeros, which are the same as the x-intercepts. Those are different. I really should have saved that for when I was 3 answers. And it would have been a bingo, bango, and bongo. All right. If you know it, a total of 12 apart, then I hope you got that it's halfway would be 6 over from the 9, which makes it at what? 3 is correct. Another way you could do that is simply by averaging 9 and -3. You average them by adding them together. That makes 6. Counterintuitively, that and that makes 6 when you add them. Divide it by 2 makes 3. X equals 3. But that's not the final answer. Mr. Z, tell me what to do to find the rest of it. Good. Write me the equation. think it's a 9. Okay, we're close. And then did you, okay. It's not, no, there's no vertical. Oh, yeah, you're right. There is a vertical flip. It's upside down. Sorry. And the other thing I was looking for was, I don't know if you noticed this. There we go. Okay. Now, Miss V, tell me what to do with this equation. You are right. And did you notice these came out opposite? 6 and negative 6, which makes negative 36. And you double it, which makes double 72. And then is it, this was negative, and the other answer was negative. It makes it positive 72. Did you get 3 comma 72? All right. Yes, sir. Question?
Okay, so can you just multiply 6 and negative 6 since each point, each 0 or root or bingo bongo is 6 from the line of symmetry? That's what I was asking.
Okay. Yes, you are right that it's going to be 6 times negative 6 is going to be part of your equation. But you don't want to just do that because then you might forget to multiply by 2 and to multiply by this negative in front. So my best advice is, and 9 times out of 10, they're going to ask you, what's the equation? And then you got to write the equation anyway. So anyway, find the equation first. Then all I got to do is stick the 3, the dotted line number, into the equation, and that'll tell you the y. All right, one more, and this one is just words. So, of course, you need more than words to be able to answer this question. Anybody get the reference there? It's a song title. Anyway, would you please tell me if this, what's the equation first? And then what is the vertex for said equation? And here's my clues. The roots are negative 2 and positive 8. It's got a vertical reflection and a stretch factor of 3. What is the equation for that? And what is its vertex? Remember, draw a picture. Pause while you give that one a shot. All right. So, Sonny boy in the back row, I want you to read me the y equals equation for this thing.
Okay, so y equals, wait,
The equation. Just write me the equation. Do you need to phone a friend? Okay. There's some people over here that know. Ask some people nearby. Okay. Ask somebody who's willing nearby. All right. This kid with the Batman outfit. Yes, go ahead.
negative 3.
Why'd you put a negative 3 there? Yup. Okay, and then what? You are so right. Nice job. Raise your hand if you guys had that right. Good. And then the little vertex line, the dotted line that runs down the middle. What do you mean, runs down the middle of what? That's why I said you should make a picture. Okay, so if it touches at negative 2 and positive 8, you know it touches here, and you know it's an upside down parabola, and it really does help you to get the big picture of, oh, it must be running right around there. So if you think the dotted line's at 7, you'll realize, wait a minute, I think I screwed up. Okay, dotted line must be like 2, 3, or 4 or something like that. Miss LF, what did you think the dotted line was at?
3.
X equals 3. And then if it is at 3, it's 3 comma something. How did you do that part? Did you notice that you got a 6 and, no wait, a 5 and a negative 5, which are opposites, and therefore positive, no, negative 25 times by negative 3, 75. 3 comma 75. Raise your hand if you had that one right. Okay, good. Now, last thought. Now that you know the vertex, write it in vertex form. Write the equation for this same parabola, except in vertex form. I'll pause for a second while you try that one. All right, so hopefully you knew that you just write y equals parentheses x and the squared. That's how you'd start. And then the vertex is 375, so I slap in a 3 and a 75, but this is really important. Which of those do we trust outside, and which don't we trust? And therefore, we use the opposite of 3, which is minus 3. All right. Then, so easy to forget something. What did I forget? Yes, sir. The negative 3 on the outside right there. If you understand that, raise your hand. Okay, good. That's vertex form. This one was factored form. The green one here was factored form. What if the only other topic, I don't think there might be only one thing we haven't done, and that's general form. To get general form, generally, you just FOIL it out. Okay, so what if there's a number in front? Please show me, oh, I'm going to throw a negative number in front like that. Show me that you can multiply that all the way out carefully. If you don't do it in the right order, you will mess it up. So we're getting factored form to general. Mr. FD, do the foiling for me.
First I would multiply -2 by x and -3.
You can actually do it that way. You could multiply these out, but I don't usually recommend that because it gets messier than if we just do the foiling first. Could you just roll with it and try to do the foiling part first? Okay. Yep. Correct. Perfect. Now you do that -2 that was on the outside to everything. Final answer. Got it? That's it. And what is this good for? Tells you something. Y-intercept. What is this good for? Tells you something. The roots, the zeros. How about the x-intercepts? How about the solutions? All the same thing. That's what's good about that. And also, one other form, and that's the really, really obvious one. What form is that in? And it tells you the vertex, duh. Okay? All right. That covers pretty much everything you've learned. Now, let's talk about, just for a few minutes, the last complicated factoring ones. This is called difference of squares. That's its fancy name. This is how you do it. Square root of this, square root of that, and then 1 plus and 1 minus. How can I prove it works? FOIL it out. And it's first out x squared, outside, -4x, inside, +4x, and those cancel. And the last is that times that makes -16. Final answer, x squared minus 16. Looks like I did it right. You can know you're right on these. Please take advantage of that when you're tested on it. You can FOIL it back out to make sure it worked. If you didn't factor right, you'll know, because when you FOIL it, it won't come out right. All right, how do you do it when they're more complicated? Like, let's say 25x squared minus 144. Well, it's the same exact process. Who could explain it to me? Go ahead. You're close. There you go, 5x. 5x. -12 and 12. Good. If I'm wanting to make sure I'm right, I go first, 25x squared. Outside and inside, I don't even know what they are, but they're opposites of each other, so they'll cancel. I think it's 60 and -60x. And then the last, 12 times 12 is 144. Slap on a negative, -144. Is there anybody who's still smart enough to be able to do this? I taught you yesterday, or Friday, sorry. 3 people, maybe. I'll try the guy in the blue. Go ahead.
Isn't it x minus 4 and then x plus 4?
Both the 4's have an I on them. You are right. Okay. That's because it's a plus. In general, we want you to know that these won't factor with normal work, but when you throw in that I thing at the end, it works because your firsts make x squared. Your outside and the inside are opposites, so they cancel. The secret sauce is in the lasts. That times that makes 16, a negative 16I squared. And the I squared is really a negative 1, and that makes it negative 16 times negative 1 is positive 16, so it actually works. Okay, so here's about the hardest one that you'd have for today. 16 x squared minus 36. It factors, but a lot of people are going to go factor it wrong. Boom, boom. Think a little bit. Do something carefully. Okay, try that one. You just did it fast. You didn't do it right. There's fast and there's right. And then there is right and fast. But only do that when there's a plus. This one with a minus, you don't do that kind of thing. All right. So here's the common answer. Okay, square root of this, 4x, 4x. Square root of that, 6 and 6, and 1 plus and 1 minus. And you can even argue that you FOIL it out and it works. So why could it possibly be wrong? It's wrong. Because it's factored, but it's not factored all the way. Do you get that these both have a 2 in them? And these both have a 2 in them? So you got to factor the 2 out, and then factor the 2 out. So this is the long and painful way. So who knows the short and easy way? Yes, sir. Factor a 4 out right away. Let me do it that way in the red here. I'm going to factor a 4 out, and I get 4x squared minus 9. Then the 4 is already factored out, and I can just do this one with the 2x and 2x and the plus 3 and the minus 3. There's your final answer, and it only takes 2 steps. As opposed to if I factor the 2 out here, it's 2x plus 3 and 2x minus 3. And this is right. I still haven't finished, though, because I got to put that and that together. 4 out in front, 2x plus 3, 2x minus 3. So either way, you'll come up with that, but there's a hard way and the easy way. And believe me, when the cop asks you, so we're going to go down to the station, you want to make this the hard way or the easy way? Always pick the easy way. Because they have pepper spray and they have mace. How does this affect your math class? All you have, well, that's true. Actually, mace doesn't have to be pepper spray, but there's a new gun I've heard. They now have guns that will fire pepper spray. I thought that was an interesting one. It's not like a squirt gun. That's a good point. It fires pellets, and the pellets, as soon as they hit, they use the ghost pepper. Have you heard of ghost peppers? Yes. Like there's super spicy peppers, okay? And it uses the ghost pepper so that anybody within 5 feet of where that ball explodes is going to, like, instantly, their eyes and their lungs are not going to completely shut down, but they're going to constrict enough where they're going to be just like barely surviving kind of thing. So it's non-lethal, but anyway. All right. So the point was, if you have a choice, do it the easy way. I'm going to give you one more that's like that. There is always that chance, and there's always a chance when the cop fires even a taser that the person might die from it, especially because a lot of the people are already under the influence of drugs or whatever, and then they get partially electrocuted. It doesn't mix too well, and so, there is a chance with the non-lethal methods can sometimes cause the person to die, which is obviously horrible. All right, so let me think here. What would be something I could put over there that would make this work nicely? There we go. You know what? I'm going to leave this one up there. It's not exactly what I intended, but this one can factor, but it's not kind of how you'd expect. So everybody just factor this as well as you can. We've got a few of these on your homework where you're going to be in the middle of factoring it going, what is going on? Because they're not normal. But the question is, have you factored it all the way? That's really what the question is. So do you get, you can take a 2 out of both of them? But if you do, you won't have factored it all the way. Do you get, you can get a 4 out of both of these. But if you do, you won't have factored it all the way. Let me show you. If you take the 4 out, what happens here? 4 comes out and you got 25x squared minus 10. But do you get there's also a 5 that can come out of both of these? So I really should have taken out something bigger than a 4 in the first place. What can you take out?
20.
A 20. Very nice. Now, I know some of you are thinking, but if you take out 20, you won't be able to factor it any further. But if you take out 20, sometimes that's the best you can do is take out the biggest GCF, greatest common factor, that you can find. So it's 5x squared minus 4. No, 20 times 4 is not 40. 20 times 2. There we go. And that's it. It's done. You can't factor it any further. There's a couple on your homework like that. Don't expect everything to factor all the way down to something perfect and easy and beautiful. Sometimes you just have to say, well, I factored something out, and that's all I can do. This can't factor any further because it's not a difference of squares. That's not a perfect square, and that's not a perfect square. If this had been x squared minus 16 left after I had taken out like a 2, you know, like let's say it had been 2x squared minus 32. Try that one. Can't factor it like right away, just factor something out of it. Miss P, tell me what you factored out. Excellent. What'd you have? Two times what? There you go. Squared. Keep going. Minus 16. Can I just stop there and say, yay? No, I have to keep going. I go 2 and then another 2 parentheses, x plus 4, x minus 4. That's factored all the way. Raise your hand if you had that one right. Okay, good. That's all we needed to know for today's homework. Now let's just jump right onto the homework and I'll start it with you together. It is called factoring. Here, I'll pause for a second. Okay, in factoring worksheet C, we need to shorten this up a smidge because even though they're not too tough because you guys are pretty good at factoring, there's too many. 3 and 8 and 11 and 14 are all gone, but I want you to do the rest of them. Can't seem to cross that one out. It wants you to do it. 14 is a cross off also. Okay. Let's jump down to a more challenging one. Let's try number 5 right off the bat. Nothing seems to be factored out of both of them, but you have to use that difference of squares trick. It factors because it's a difference, meaning a subtract, of 2 perfect squares. The 9 and the 4, 9x squared and the 4 are both perfect squares. Mr. TB, would you tell me what you think it is?
3x.
Correct. You've got it. And if you wanted to be sure, you'd just FOIL it out. Oh, wait a minute. 4 and 4 doesn't make 4. Ah. Sorry. Plus 2 and minus 2. Sorry about that. First, make 9x squared outside and inside cancel. Last, make negative 4. It's right. And Honestly, that's exactly why you need to FOIL them out, because you can just make a dumb mistake like that, and hopefully you won't go 4 times 4 is 4. Well, wait a minute. Ah, you'll catch yourself then. Yeah, you did it. Blame me. I was just, 3x squared minus 1. There, that one's done. That's one of the most common wrong answers because you can factor it again. Do you get that this factors into two things? Because it's perfect squares. 1 is a perfect square because it's got a nice square root. What's the square root of 1? 1. So, what do you think? 3 times? Yep. All right. Now, the review problems near the end are actually the most important ones because factoring is definitely part of this next test that you have. But the hard stuff is the stuff we practiced at the beginning of the hour and the stuff that's at the end of this worksheet here where you have to pull it all together. So, here, create your own difference of squares. X squared minus 16. There, I created a difference of squares, but you can't use mine. That's a difference of squares in case you haven't caught on to the name. That's what those problems are called, difference of squares. And then create yours where a does not equal 1. The a is the number in the front. Right now I have a little mini 1 times x squared there. But make that so it's still a difference of squares, but that lead number can't be a 1. You have several examples from your test, but make one of your own. All right, and this equation, it's weird because it has an a at the front. Isn't that where the stretch factor would normally go? All right. The axis of symmetry is that dotted line thing that runs down the middle. I'm going to give you a new way to get this besides the dotted line way. The dotted line way works, but there's an equation for that. There's an app for that. X equals negative b over 2a. Do you recognize that that's the beginning of the quadratic formula and the end of the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. It's got the negative b and the all over 2a. Very beginning, very end. That little formula tells you the x of your vertex, which is the axis of symmetry line. Okay, so what is negative b? Well, that's b. So what's negative b? Negative 2 over 2 times a. What's our a term? Nope. A. In this case, it has an a right there. So it's negative b over 2a, which in this case means, here's the b, is 2. Negative 2 over 2a. And that's it. I know it freaks people out sometimes to have a letter in your answer, but if there's a letter in the problem, well, there's probably going to be a letter in your answer. Technically not a letter, it's a variable, but you get the idea. All right, the zeros, those spots, that's not too tough. I can look at the picture. Oh, wait, it says not drawn to scale. Ooh, scary. So that means I can't trust that those spots are actually where they are. So then, if I'm going to write this equation, I'd have to write it out using my vertex. And let me see if I can move this thing. The zeros of the function. You know what? I think, oh, I know. The zeros are still the zeros either way, whether or not there's a stretch factor. So even though it says not drawn to scale, you can still count on the fact that this is at 1, 2, 3, 4, 5. That's at negative 6, and that's at positive 2. You can still trust those numbers, because even if there's a stretch factor, they'll still be the same. So we know the zeros. They're the x-intercepts right off the graph. And don't worry about the whole not drawn to scale thing. That just means that we don't know the stretch factor. And then the y-intercept, finish this sentence. Really powerful saying. Happens pre-calc all the time. They'll ask you, what's the y-intercept? And you can't just see it in your equation. So you have to say y-intercept is where x equals 0. Good. So you just stick in x equals 0 into this equation right here. And boom, you'll have your answer. The y-intercept is where x equals 0. Put zeros in. You know what the y-intercept is. You'll be done. Done. Piece of cake. Okay. So that's a big healthy portion of review for your test, which is not tomorrow, but the next day. Tomorrow will be another review day. where we won't even have these factoring questions to deal with. It'll just be all review. And then Thursday, hopefully you're ready for your the more challenging test than your last one. Okay, I don't think it's impossible because we've been practicing a lot for it. But in general, these next two tests, the first one isn't as bad. The next one after that, the one we have on Thursday is not too bad. The one after that, really tough. Doesn't mean you can't get an A, but it does mean you're going to have to try harder for that A. All right, that's all I have for you for today.